Hello, welcome to the class of Advanced Stats and Econometrics. In today's lecture, we are going to discuss economic forecasting. So, time series econometrics, four important topics in time series econometrics are forecasting with linear regression model, univariate time series forecasting with Box-Jenkins methodology, that is called ARIMA, auto-regressive integrated moving average, multivariate time series for forecasting using vector autocorrelation, and nature of causality in econometrics. Forecasting with linear regression models. It has been used since long time in forecasting sales, production, employment, corporate profits, and many other economic topics. Point and interval forecast. In point forecast, a single value for each forecast period is provided, whereas in interval forecast, we obtain a range or an interval that will include the realized value with some probability. Ex post and ex ante forecast. Ex post means after and ex ante means before. So in the ex post forecast period, the holdover period, we also know the value of the regression and regressors. Conditional and unconditional forecast. In conditional forecast, scenario analysis or contingency analysis, we forecast the variable of interest conditional on the assumed value of the regressors. In unconditional forecast, we know the values of the regressors with certainty instead of picking some arbitrary value of them, as in conditional forecasting. ARIMA method of forecasting. ARIMA is auto-regressive integrated moving average. So let us begin first with AR model, auto-regressive model. The following is an ARP model. P means P period lag. So YT will be regressed on its own value P period with a P period lag. So YT is a function of YT minus 1, YT minus T, YT minus 2 till YT minus P. So this can be written as Yt is equal to B naught plus B1 times Yt minus 1 plus B2 times Yt minus 2 plus B3 times Yt minus 3 till Bp times Yt minus P plus Ut, where Ut is a white noise error term. Moving average model. We can also model Yt as an MAQ. MA is moving average model, a weighted or moving average of the current and past white noise error terms. So YT can be written as C0 plus C1 times UT plus C2 times UT minus 1 till Cj times UT minus Q. So ARMA model. ARMA PQ model is a combination of AR, autoregressive, and MA moving average model. So PQ means P period lag in AR, autoregressive model, and Q is lag in MA model. MA model is based on the residuals. Autoregressive integrated moving average model, ARIMA model. The Box-Jenkins methodology is based on the assumption that the underlying time series is stationary or can be made stationary by differencing it one or more times. This is known as ARIMA PDQ model, where D denotes the number of times a time series has to be differentiated to make it stationary. So you have a time series which is non-stationary. If you difference it, take the first difference and it becomes stationary, then value of D is 1. If you need to take the difference 2 times, then it is integrated of order 2 and the D will take value 2 and so on. BJ methodology to determine which model is appropriate follows a 4-step procedure. Step 1, identification. Determine the appropriate value of P, D and Q. The main tool in this search are correlogram and partial correlation or partial correlogram. Step 2 is estimation. Estimate the parameter of the chosen model. Step 3 is diagnostic checking. Check if the residual from the fitted models are white noise. If they are, accept the chosen model. If not, start afresh. That is why the BJ methodology is an iterative process. Step 4, forecasting. The ultimate test of a successful ARIMA model lies in its forecasting performance within a sample period as well as outside the sample period. This is really important in the sense that the time period for which you are going to forecast uh, may change the result. So, if it is within the sample period as well as outside the success sample period, then it is a successful ARIMA model. Vector auto-regression or VAR. Vector auto-regressive model. VARs are used to deal with forecasting two or more time series. In VAR, we have one equation for each variable, and each equation contains only the lagged value of that variable and the lagged value of all other variables in the system. As in the case of univariate time series, in VAR, we also require the time series to be stationary. If each variable in VAR is already stationary, each equation in it can be estimated by OLS. If each variable is non-stationary, we can estimate VAR only in the first difference of the series. If individual variables in VAR are non-stationary but are co-integrated, we can estimate VAR by taking into account the error correction term which is obtained from the co-integrating regression. This leads to vector error correction model or VCM. Nature of causality. VAR models can be used to shed light on causality among variables. The various idea behind VAR causality testing is that the past can cause the present and the future, but not the other way around. Granular causality. In establishing causality, we must make sure that the underlying variables are stationary. If they are not, we have to difference the variable and run the causality test on differenced variable. However, if the variable are non-stationary but are integrated, we need to use the error correction term to account for causality, if any. Granger causality test. So, steps are first regress current y on all lagged y terms and other variables, if any, such as trend, but do not include the lagged x term in this regression. This is the restricted regression. Obtain the restricted residual sum of square RSS small r. Re-estimate the equation including the lagged x term. This is the unrestricted regression. From this regression, obtain the unrestricted residual sum of square, that is RSS UR. The null hypothesis is that lagged x term do not belong in the regression. To test the null hypothesis, we apply the F test, which is basically a ratio of two chi-squares divided by their degrees of freedom. So RSS in the restricted model minus RSS in the unrestricted model. Remember, RSS in the restricted model is always higher, so it is always positive. Divided by M, M is the number of restrictions, and divide everything by RSS of unrestricted model and divide by the degree of freedom, that is n minus k, where n is the number of observation or sample size and k is the number of parameter estimated in the unrestricted regression. Okay, if the computed f value exceeds the critical f value at the chosen level of significance, we reject the null hypothesis. Granger's causality test. Run the test again, switching x and y. There are four cases. Unidirectional causality from x to y, unidirectional causality from y to x. Feedback or bilateral causality is indicated when the set of x and y and x coefficients are statistically significantly different from 0 in both regression. Independence is suggested when the set of y and x coefficients are not statistically significant in either of the regression. And the reference for all this is a book titled Econometrics by Example. Second edition, publisher is Palgrave Macmillan, and the author is Damodar Gujarati. That's it for today's lecture. Thanks.